Welcome. Let's try to solve another Leetcode problem. 2918. Minimum equals sum of two arrays after replacing zeros. I think this problem is a very interesting problem. Basically, it is just like a simulation. So we have two arrays, nums1 and nums2. So inside the arrays, there will be zeros. So for example, in nums1, there are two zeros, or it can be nothing. So this one have 1 0. So we can replace all the zeros in both arrays with strictly positive integers. So for example, for this array, we can replace the zeros with positive integers, maybe 1 or 2. And also for nums2, and we want to return the minimum equal sum you can obtain, or -1 if it is not possible. So for this example, nums1, the sum of them is 4, but here the sum of them is 5. So this is 5 and this is 4. As we can see, that is not possible. Yeah, because for nums2, the sum of them is 5. But for nums1, we have to replace this 0 with 1 and another 0 with 1 at least, or maybe 2. As you can see, the sum of them is 6. But here, the sum of nums2 is 5. It means it is not possible. We're going to return a -1. But for this one, the sum of nums2 is 11. The sum of nums1 is 6. Yeah. So this means if there is a zeros inside the nums1 or nums2, definitely it is possible because this 0 can be any positive numbers. But we want to get the minimum sum of nums1 and nums2 after replacing. So what we can do? Maybe we're going to replace this 0 with 1 because we have to do that. Yeah. So what is the possible maximum number of nums1 and nums2? So for nums1, maybe we want to replace this 0 with 1 and this 0 with 1. So what is the maximum possible sum of nums1? It is 5 plus 1, 1, 1. So it is 8. What is the maximum possible sum of nums2? So we have to replace this 0 with 1. So it is 12. So for nums1 and nums2, if there is zeros inside nums1 and there is also zeros inside nums2, and we can calculate the maximum possible sum. This is 8 and this is 12. So what we're going to return? We're going to return the maximum value of this 8 and 12. Yeah, because maximum sum of nums1 is 8, nums2 is 12. So we have to let this nums1 equals to nums2. 8 is not equal to 12, but we replace the 0 with 1. What about we replace the 0 with some other numbers? So for example, 1, maybe 5, or maybe 6. If we replace 1 with 6, the sum of them is 12. It is possible. Yeah. But we just need to return this 12. It cannot be smaller. Maybe you think 11, but it is not possible because here is a 0. So this is why. Now let's just start simulation of the problem. So we're gonna have S1 and S2. So it's gonna be the sum of nums1 and the sum of nums2. Now we are going to have a count of zeros in nums1 and nums2. So I'm gonna define two variables, 0, 1 and 0, 2. It's gonna be nums1 count with 0, and similarly nums2 count. We're gonna count how many zeros inside nums1 and nums2. Now we are going to check the possible sum of nums1 and nums2. So we're gonna define a p1 and p2. It's gonna be S1 plus the number of zeros, because we're gonna change the number of zeros to 1. So the sum of 1 gonna be S1 plus 0, 1. And similarly, it's gonna P2 would be equal to S2 plus 0, 2. Yeah. So the meaning is we count the number of zeros. Maybe for this one, the number of zeros is 1. So the sum of them, the possible sum of them is 11 plus 1. And this will be 6 plus 2, gonna be 8. Yeah. But we cannot return the maximum of P1 and P2 yet. We have to check it because it can be a negative result. It can be a -1 because it can be something. it can be impossible. So for this example, it is impossible. But how can we check that? So we're gonna compare. So if after calculating the P1 and P2, so we're gonna compare. So if P1 in this example, if P1 possible, it is 6. Yeah. If P1 is bigger than P2, so P2 is the sum of nums 2, and there's nothing, and there's no 0 inside, so the sum of them, P2, gonna be 5. So if this P1 equals to P2 and 0, 2 equal to 0, because this is no zeros, so we're gonna return a -1. So this is one case. For nums 2, there's no 0, because 0, 2 equal to 0, it means there's no 0. So the maximum, the sum of nums 2 is 5. But the least sum of nums 1 is 6. So this means it is not possible. So this is one case. And similarly, there's another case, or, so we can use or another case. So the other case is the P2 more than P1, but 0, 1 equal to 0. So this means inside nums 1 there's no 0, but the sum of them is less than nums 2. Yeah, there's no 0, but this definitely gonna be less than nums 2. We're gonna return a -1. Now let me run it to check. As you can see, it works. Now let me submit it to prove it can pass all the testing cases. As you can see, it's pretty fast and passed all the testing cases, and the time complexity is O m plus n. M is the length of nums 1, n is the length of nums 2. As you can see that it is 10 to the power of 5, so that is why it can pass. But do we need to prove it? So the idea is just like a greedy idea, and the method is just like simulation. We can simulate it like this. So maybe you think, so for this P1 more than P2, yeah. But can we use P1 not equal to P2? So for example, this P1, so for example, this P1 is 6, and this P2 is 5. Maybe, yeah, maybe this P2 is 7, and this is 6, but that is possible. So for example, the sum of this one gonna be 6. Maybe this is 3 and 4. It is 7. Is this possible? Yes, it is, because before that we choose 0 as 1. It is 6. But now we're gonna choose 7. Is that possible? Yes. We can just replace this one with 2. It is possible. So this means we just need to check P1 more than P2 and 0, 2 equal to 0, like that. If it is not equal, we cannot check like that. Yeah, I mean P2 more than P1, it is not, yeah, if P2 more than P1 or P2 equals to P1, even 0, 2 is 0, but that is still possible. We're going to return the maximum. So the only case is that the P1, yeah, let me just clean it. So the only case is here. So the P1 here, so for this example, the P1 is 6, because at least we're going to choose a 1. The possible, the minimum sum of nums 1 going to be 6, and here definitely going to be 5. So the P1 more than P2. But there's no 0. It means we cannot adjust, we cannot increase the sum of nums 2, because there's no 0. So definitely we're going to return a -1. And similarly for P2 more than P1. But if 0, 1 equal to 0, because it's here, if here is no zeros inside, definitely we cannot adjust it. So for example, we have another example. For example, nums 1 is 2, 2, and nums 2 maybe 1, 4, and 0. So the sum of nums 2, for example, it must be 6. The p2 equal to 6. So the p1 and p2 is just possible of nums 1 and possible of nums 2. So here, possible of nums 1 gonna be 4. Yeah. So here, this p1 less than p2, 4 is less than 6, but there's no 0 inside. This means we cannot adjust it. So we have to return a -1. Now let me submit it again to Tag. Yeah, I think the coding like this would be easier to understand. As you can see, it's pretty fast. Thank you for watching. See you next time.